Well, hello everybody. Welcome back to the home build. Today we're going to talk, it's an exciting video. We're going to talk about stair framing, its components, comparing those to the drawings, how you figure riser, treads, elevations, landings, all that sort of thing. So let's go ahead and get started. We're going to first take a look at the drawings. So our stairs are completed, but it's a good thing to review, to see, check how they've done it, codes, whether or not they did it correctly, and that sort of thing. So let's dive in the plan. So first, we got our stairs here. It goes up, over, and then up to the second floor. There's a couple supports above and below. So when it's a dashed line, it means that it's underneath. So taking a look here, here's our dimensions of where the center rail is, how far our landing's out. Okay, the stairs above your landing has to rest on top of your landing unless it has some sort of hanger. In this case, it's going to rest on top, so the landing has to be underneath it. So looking at the second floor drawings here of the floor, we're going to have two beams supporting your floor. So here's one beam going to support the upper end of our risers and treads, our stringers, where they end up. It's a beam per manufacturer, or beam per engineer. Here's our width, the supports, and that sort of thing. So let's take a look at that real quick first to make sure it's going to be supporting. So we got LVLs right up here, okay, being supported. So cross support, hanger on top of the wall. So then this becomes a bearing wall. That's not something that you want to remove. Okay. Supporting the end of our framing here, it's going to be a wall above, like it is there. Another LVL, and it's resting on top of that 2x6 bearing wall. So if it butt into it, you need to have some sort of equivalent hanger to be able to support it. So the components of a stair, we got a stringer, a tread, and a riser. Okay, looking down here, we got the stringer, we have a riser, and we have a tread. If you look at how they're built, the riser supports the tread. So when you stand all your weight right out here in the middle, it doesn't deflect. Okay, glued and nailed. Gluing is important. The gluing helps with the squeaking as you walk up and down the stairs. Okay, a spacer right here spaces the stringers off of the wall. Nails to it allows the sheetrock to go on by, and as well as the skirting trim for your stairs. Okay, if you had to cut in all around every single one, it creates kind of a weak corner right in here, and that sort of thing. Down at the bottom, we got another beam supporting our landing right here. Okay, components of it, 2x8 framing, beam over there, nailed good and well to the center post. Okay, later on, this will get framed in right here for an opening, so we have access to storage underneath. It's going to be a wall on the pickup work right over in here. Okay, for the toilet, or the back of the toilet rather. Now let's go and dive into the plans again so we can figure out what is that riser supposed to be, what's the tread supposed to be, and that sort of thing. So on these set of plans, Adair, they do a great job on their details of their plans. We got to look at the details. All right, so what we got here, some codes that it's requiring: max riser height. Get that into focus. But anyhow, it says max riser height is 7 3/4, 3/8 max variance, minimum tread depth of 10 inches, max of 3/8 variance, and nosing projection 3/4 minimum, 1 1/4 inch maximum. Okay, every jurisdiction might be just a little bit different, so check your jurisdiction to see what those codes are. Commercial, completely different ball game. So that's what we got here. So some other things down at the bottom of our riser, it calls for a 2x4 kicker plate up at the top where it meets the wall of the landing. It's got anchors. It's a Simpson 834 anchor in this case, as well as up at the top, and as well as a ledger up at the top to nail into. So the landing and the second floor, those are your treads. Those are the face of your risers in this case. So you build it accordingly. So let's take a look now at how you figure what your riser, what your tread is gonna be. So the first step, what you gotta figure out is your total rise. In this case, I got an L-shaped, a U-shaped stairs. So I'm gonna take a measurement from subfloor up top down to subfloor at the bottom. If I have differences in flooring, you gotta take some account for that as well. So measuring from the very top down to the bottom. So I'm gonna measure from the bottom, or the bottom of the sheathing. So we got right here down to the subfloor. All right, from the bottom of the subfloor of the second floor down to the subfloor of the first floor, we have 10 foot 3.5 inch. Adding 3/4 from the second floor, that gives us 10 foot 4.25 inch. So that's our total rise. Okay, there's a few different ways depending on what type of calculator or calculations you're gonna do. In this case, I'm gonna use Construction Master Calculator. They're easy, okay? So we got 10 foot 4.25 inch, okay? This particular case, there's 16 risers, okay? I could divide by 16, gives me 7.75 of an inch of a rise, okay? Which just happens to be the maximum as well. So there's not much variance that we can have there, okay? So that's the max. Another method is if you check your riser height that's stored in your calculator. So recall 7, I stored 7.75 as my riser height. Then I can enter in the rise, 10 foot 4.25 inch rise. And all I got to do is press that stair button. It's going to give me a whole bunch of information. But what it does say is 7.75. That's my riser height. Okay, so we established that. The other is, let's establish where our landing height is. Because we're going to split it up, we don't want it in between a rise or run. So we want it right on one of those riser heights. So let's take a look at that. So for this case, we have 9 risers to get to the top for our landing. We got 1 riser, 2, 3, 4, 5, 6, 7, 8, and 9 right here. Okay. So if you take 7.75 inch, that's what we figured as our riser height, times 9, gives us our finish grade for our landing, 69.75 inch. Perfect, but we got 69.5 inch. It should be 69.75, but it's real close. Okay. If we had an 1.1/8 plywood on that upper top, just like it is on the treads here, that would give us that 69.75 inch. So it's framed correctly. Debating whether or not they need to add another 1/4, 5/16 of like a AC plywood, some sort of finish on top of that to give us a uniform riser height. Okay, so we established that. It has our dimensions, how far out and over, but you can see on that second floor, the landing has to stick out past for the stringers to land on top of that. Okay. So let's see what other information the calculator has. So if we cleared it, entered in our total rise, 10 foot, 4 1/4 inch is our rise. Press the stair button, is our riser height, number of risers, overage, underage, tread width. So prints, they call for a 10-inch minimum tread. So measuring from riser to riser, we have a little over, well, right at 10 inches. But by giving it a nosing of 1 1/8 gives us right at 11-inch riser depth. Okay, gives it a little more comfortable. Some jurisdictions can be a little less, but in this case, that's a comfortable stair. So ideally, that the angle of this stairs and those stringers right there needs to be between 30 and 35 degree angle, which according to this works out. Also, rule of thumb, if you add your riser and your tread together, they need to be added together between 17 and 18 inches. So 6 3/4 plus a 10-inch gives, excuse me, not 6 3/4, 7 3/4 and 10-inch gives us 17 3/4 of an inch. That's a comfortable angle, okay? So we got our tread width of 10 inches. Press the stair button again, 15 treads. You always have one less tread than riser. Okay, if it was a straight run, it'd be a, there we go. Stringer length would be 15 foot 9 3/4. But I figured you got to figure it separately from this section and where you turn to go up to the next section. So we figured our elevation, 69 3/4 for a landing. Lots of work being done. So we have 69 3/4 of an inch as our rise, okay? And I can press stair, gives us the number of risers, gives us the number of treads and the dimension, okay, 8 treads, and then gives us our, oops, it gives us our angle just slightly over our comfort angle, 30 to 35 degrees, but still works. I'm gonna have to cycle back through to get that stringer in. All right. Staircase, there's our headroom, so we don't hit our head as we're going up. Floor thickness, riser height. Stairwell opening, and our stringer length, 101 3/16 of an inch. Okay, 8 foot 5 and 3/16. That would be measuring from your top of your riser to your top of your riser, or your bottom of your riser to your bottom of your riser. Okay, that's what your stringer length. That helps keep everything uniform as you're building it. Okay, so let's double check some of these measurements and see how they did. So down at the bottom, we got 6 3/4, 6 3/4, a little more, so a little bit off there. So when you get up to the top, what's gonna end up happening is you're a little less. But if you add that same floor thickness, then it becomes the same riser height. So I think they're gonna have to add a little layer of plywood up there so that that riser becomes the same as all the others. All right, let's have a look at where your stringers are attached to your landing. So right up here, this particular case, the stringer is gonna need to have some sort of extra support. Sometimes it's a wall underneath. This case, it's a beam, which is awesome so that I can have additional storage underneath. So underneath, they added a header here, supported by a trimmer, so it's got good support. And then it's got these Simpson hangers that help tie it in place. Got a pressure block, as well as a stiffener here, which is great. So it's going to be a nice strong stringer. Stringers are supposed to be at 2x12, which they are, but nailing on this gives it a little more strength to it. I don't see any overcuts right here. Nice and tight, which is great. And all their joints of the framing they did here, nice and tight. If it's all gappy, then it allows for movement to happen. So, done very well. So let's lay out a stair stringer for this particular stringer. So we got an elevation of our landing 69 3/4. We need to enter that into our calculator. 69 inch 3/4. That's our rise. Okay. And then press our tread. What we need to figure out is make sure our board, our 2x12 is long enough. And by having that as our rise, stair, over genderage, and then we got a stairwell opening and stringer length. So enter that as feet. We need at least a 2x12 that is greater than 8'5" 3/16", so somewhere around 10 foot would work. So in this particular mock-up here that I represent, I got a 16-foot 2x12. Yes, it's plywood, but it's just for kind of demonstration purposes only. So definitely going to be long enough. Okay, so what I have is 7 3/4. So I'm going to go back 69 3/4 of an inch is my rise, and I'm going to press stair. I got a 7 3/4 inch rise for a riser, and our tread is 10 inches. So using a framing square, we're going to go towards the end. We're going to use 10 inches on the blade, the tongue 7 3/4. Okay, with some riser, some stair gauges, or excuse me, square gauges. I could just put those on, or in this particular case, I'm gonna hold right on the edge, 7 3/4. 7 3/4. I do it right. So 7 3/4, and we have 10 inches. So I'm just randomly coming in on the end, right like that. So this becomes my first riser. I'm going to extend that all the way through. So this is the bottom. This is the bottom of the stringer. Okay. Then I can stair step it. 7 3/4, and a nice sharp pencil. Okay. Another calculation that I like to do is figure out what that rise, run, and the diagonal is. So I got a rise and a run. I got 7 3/4 as my riser, 10 inches as my run. I want to know what that length is right there in this particular case. So it would be 10 inch as my 7 3/4 rise, 10 inch run. Okay, then I press diagonal 12 5/8. So it's kind of a double check to see that you're doing it, you're not growing or shrinking. We got 12 5/8. It's exact. Okay. For the number of risers we have, we got 1 2 3 4 5 6 7 8 9. That's what the calculator also came up with. So 12 5/8 is my diagonal. So I'm going to press plus equals, and I'm going to just keep adding that together, and I'm going to make all those marks where my diagonals are. So I got one here, and then I want to also mark 25 and 5/16. so that right there, I can make sure, because my calculator's got a little rounding, I don't want to be adding, subtracting. So I'm going to hold 7 3/4, make sure I'm on 10 inches. So right now, if I held it on that line, I'd have grown or shrunk just a little bit. Okay, so by doing that, I get lined up just right. Make my mark. Okay. And then I'm gonna press equals again. It adds that next 12 5/8 for me. So 37 5/16. Always holding the same spot. 37 15/16. Right there. Equals again 50 5/8. 50 5/8. All the way to the end. Equals 63 1/4. 63 1/4 inch. All right, so now we got our last one at 101 3/16 with that feet, 8'5" 3/16. That's the same length as our stringer length that it came up with. So as long as I end up on that mark, I won't be adding or growing or shrinking. So we're gonna finish our step-off method with our framing square on each of our marks. So 7 3/4, 10 inch. Here's kind of a point that I want to show you. Now, as we got a little bit of shrinking happening, okay? That's the calculator's little overage and underage. So I want to make sure I stay on my true marks. So for accuracy. So 7 3/4, 10 inch. That one's back on my marks. Okay, if this was even longer of a stringer, a straight pipe, then I could be adding and subtracting or growing or shrinking quite a lot if I don't figure out what that diagonal is. Okay, got that there. And we got 3 more to go. So, all right. So our last riser is actually the landing up there. Okay, so what I'm going to do is I'm going to take this line and carry it straight down for a riser of our last. So the landing basically is right up here. So I carry this mark, and I can also go 7 3/4 up here, 10 inch on this side. Line it up with my riser. Slide it over, making sure I'm good. That carries down, just like that. Okay. Another thing to keep in mind is you have to drop a stringer, okay? If you don't, when you add your tread, you just grew it 1 1/8. The top will be shorter by 1 1/8, and the bottom will be an extra 1 1/8 tall. So you have to drop it. So let's drop the bottom of our stringer. Looking down here, our stringer just happens to be 1 1/8. So we're gonna drop it by 1/8 of an inch. Okay. I'm gonna mark another mark over here. 1 1/8. Straight line, dropping our stringer. Okay. So that when I add my string or my tread, this dimension stays 7 3/4, just like I wanted. Okay. So that gets cut out, and each one of these get cut out. all the way up to the top, right up here, okay? So cutting it out of a 2x12, don't overcut it, okay? If you overcut it, you decrease your strength of your stringer. So using a jigsaw, a handsaw, something like that, multi-tool, lots of things, lots of options, but don't overcut, okay? The attachment points, so this particular side right here is attaching right to my headers there, okay? When I add a riser and add the riser to the front, everything stays equal. So that's a stringer length. What's left is cutting it out, installing it, but of course this is a mock-up. That's exactly what they did there. That's the gist of a stair stringer layout. So hopefully you enjoyed this video about stair framing, the components. If you got any questions, please leave a comment below. I know that's a lot of information. There's more in books that you can look at. This is what I teach. I'm a carpenter instructor. This is what I do. This is what I teach. This is what I love. And frankly, I geek out about construction. So hopefully you enjoyed, and make sure you press the subscribe button. If you're not currently a member of YouTube, join YouTube so you can subscribe, hit that bell button so you can see the videos that I make. I make videos weekly, sometimes twice a week. So it all depends on what's going on in this house build. So that's it. That's a wrap. Hopefully you enjoyed, and I'm gonna see you next time on the home build.